So this was continuing the last problem I cut off on the last video in lecture 3. I thought just for timing wise, it'd be better to kind of cut it off there. So I want you to try this, but I'll kind of set it up for you. Again, silver nitrate plus sodium sulfate gives you silver sulfate. And again, the balanced equation is going to be helpful for what you have to do here. So again, for these types of problems, I'll probably give it to you balanced, but for notes, I sometimes ask you to do that. So they want you to find the theoretical yield and the percent yield. So I have 10 grams of this, 10 grams of that, and I need to know how much of that, and this is my actual yield. So I want you to set up a BCA table, see if you could find how much silver sulfate you should have made, and then see if you could calculate the percent yield. So here I have the completed BCA table and showing you some of my work. So again, I have to convert the grams into moles in order for you to use a BCA table. And then how I figured out who my limiting was is I saw that this is 0.0588 and this is 0.0704. This is a 1 to 2, so I need twice the amount of this, twice this number of the silver nitrate. Or you could think of it as, do I have, if I divide this by 2, do I have that much sodium sulfate? So either way you could think about it. So AgNO3 happened to be your limiting, so that goes to 0. So this goes down, and this is my moles of excess. It was not asked in the problem, but I'm just showing it for extra practice. And then here is really what I want to find out. So it's a 2-to-1 relationship, so I have to take that down by a half, essentially divide it by 2. And so I get this many moles of 0.0294 moles with 3 sig figs. And then silver sulfate's pretty big molar mass, 311.9. So I multiply that, I get my theoretical yield is 9.17 grams in that problem. And then my percent yield is just 8.9, which was given in the problem as my actual over that. And I get around 97.1 as my percent yield. All right, so the next problem has to do with Mercury 2 oxide reaction. Happens to be mercury plus oxygen produces mercury oxide, and it's mercury 2 oxide, so it's HgO. So in order to balance that, that needs a 2 and that needs a 2. How many grams of oxygen are required for complete reaction with 100 grams of mercury? So this is 100 grams, and I want to know how much oxygen I need, and then how much mercury 2 oxide do I make. So again, I'm going to pause the video and then come back with an answer. And again, solve it any which way that it makes sense. So here's how I set it up. There was no reason to really do a BCA table for this one. Because mercury is the only reactant, so oxygen is going to be in excess, and generally speaking, oxygen is going to be in excess in any burning or reacting with oxygen. So all I did was strictly a dimensional analysis where I converted from mercury to oxygen to get about 7.976 grams of oxygen. And then to find the mercury 2 oxide I made the exact same thing using the balanced chemical equation to find how many grams. Now realize that this should be 4 digits of significance because of the 100.0. So my answer should be 108.0 because it's a 0.976 when you have it in your calculator. So I like doing this problem because it shows you that you don't have to do a BCA table every time, and don't waste your time doing that, because if they're just asking for product, if they just want one thing there, I just show the BCA table so you have it in your back pocket for any type of problem that you encounter. But please note, you could solve these problems multiple ways and keep that in mind. All right, so the last problem in the note packet, I kind of want to give you just a starting point and then have you try to do this. So I have a 5-gram sample of arsenic ore, which has all of its arsenic in As2S5. It was treated with nitric acid, which is HNO3. So I put it above the arrow because we're not going to do a balanced equation here. All of the sulfur was converted to sulfuric acid, H2SO4. Then the sulfate in there precipitated out with the barium. So we put in barium nitrate to precipitate it out. So I make barium sulfate, and I end up getting about 0.752 grams of it. So I want to know the percentage of that crude oil from here, because again, you're tracking it through there. So again, I'm going to pause the video, see if you could try it, and then I will show you the answer. So here is how I set it up. Again, I know I have 0.752 grams of barium sulfate, so I could easily take some information out of that. And really what I'm tracking here is the sulfur, because that is what is being tracked through the whole process. So I know that if I add up the molar mass of barium sulfate, it's about 233, and I have 1 sulfur in there, so I could always set up this relationship. If that's one thing you do pick up on some of my examples, you always have that relationship, and you can use it many different ways. Then once I have the sulfur, I want to know how much sulfur was in the original ore, which is the As2S5. Well, I have 5 sulfurs there, so I could put that down here, because then what I like about dimensional analysis is this cancels this, and I'm left with the unit that I want, which is the grams of As2S5. So I know that that total mass is about 310. So again, there's other ways you could approach it, but I think this works the best. So I get about 0.2 grams of As2S5 as what I theoretically should have gotten if nothing was lost in the process. So I want to know how much of that was from the total, from what I started with. So if I started with 5 grams, if I put the 0.2 over the 5, I get it that's about a 4% of the recovery. And again, that's relatively logical because you got multiple steps here, very easy for that to be lost in the process. And since you're only tracking the sulfur, that is a legitimate answer.